Welcome back. The objectives of this video are to solve nonlinear systems by substitution. We're going to solve systems by graphing, and we're going to look at some possible solutions of systems of equations and their graphs. You should be very well familiar at this point in your math career with the substitution method. Using the substitution method, you'll solve one of the equations for one variable in terms of the other. You'll substitute the expression into the other equation to obtain an equation in one variable. Then you'll solve that equation and then back substitute the value into either expression to find the value of the other variable. Then you check that solution to see if it satisfies both of the original equations. Looking at the remark here, when using substitution method, it doesn't matter which variable you choose to solve for first. Choose whichever is easiest, whether it's x or y. You're going to obtain the same solution. Making your choice, you should use the variable and equation that appears easier to work with. We're going to solve this particular system of equations, and this is a two-solution case. Because we have x squared, we have a quadratic, we could have two different solutions for x and y. So let's take a look at this using the substitution method. We can subtract 2x from both sides. It appears equation 2 is going to be easier to work with. And when we subtract 2x from both sides, we'll get negative y equals negative 2x minus 1, or y equals 2x plus 1. Some of you might find it easier to work with the negative y because we have minus y here in equation 1. So by substituting our value in, our negative 2x minus 1 in for negative y, we get a new equation all in terms of x, of x squared plus 4x minus 2x minus 1 equals 7. Subtract 7 from both sides, combine our x's, and we get the quadratic x squared plus 2x minus 8 equals 0. So we've got something here that's nice and factorable. So we factor that. Factors of x squared are just going to be x and x. We don't have to group this because we have 1x squared here. Factors of negative 8 that add up to 2. So x plus 4 and x minus 2 equals 0. X can be negative 4 and x can be 2. Completing our back substitution, y equals 2 times negative 4 plus 1. Y can equal negative 7, or y can equal 2 times 2 plus 1, and y equals 5. So we have a couple ordered pairs for our answers. We have when x is negative 4, y is negative 7, and when x is 2, y is 5. Now I did check to see if they both work, and they do. We will move on, and that is the solution to our system of equations. In objective 2, we're going to graph these two equations. So in order to graph them, solve each equation for y and then use your graphing utility to graph the equations in the same viewing window. So when we solve each of those previous two equations for y, we get x squared plus 4x minus 7, and we get y equals 2x plus 1. So you'd put those into your graphing calculator on separate lines, and then you can simply use the intersection, so graph simultaneously on your graphing utility. Use the intersection function to find where they meet, or you can use your trace key. So we can see here they're going to intersect at, well, what our solution was, at negative 4, negative 7, and 2, 5 are the two locations where our line meets our parabola. And here are the steps for using the graphing method. And then finally, there are possible solutions and their graphs. Now this is the information for solving two linear equations. We didn't have linear equations. We had one linear and one quadratic in our sample. Okay, so I'll just highlight the possibilities for a quadratic as well. Okay, so if there's exactly one solution, the two lines intersect at one point. Well, in a quadratic, that's going to be a little bit trickier. We can have exactly one solution in a quadratic, but our line and our quadratic might be tangent. So we could have one solution where we've got a tangent. Now this, of course, is if we've got a quadratic and a linear equation. If we had two quadratics, we could still have one solution there, but it would be at the tangent point. We can have infinitely many solutions when two lines overlap. We might have that if two quadratics overlap, if they're the exact same quadratic. But we could also have two solutions. Okay, so here we have one solution. We have two solutions with a quadratic. That was the example that we saw where our parabola and our line met in two locations, or our line cut through our quadratic. And just like linear equations, we can also have no solution. Okay, that would take place when our parabola and our line never touch. They don't meet. So we could have zero solutions in that situation as well. And we'll wrap it up here with a little bit of vocabulary. A system of linear equations, okay, so two lines, are consistent when it has at least one solution. In this case, with our quadratic and our linear, it is also consistent because we have at least one solution. We had two solutions. Or it's inconsistent when there is no solution. So a little bit of vocab there for you to keep in mind. You might see that as well. So an introduction to the substitution method, and we'll get some more practice with that when I see you in class.